Hello and welcome to Blender Modifiers. Today I'll guide you through the basics of how modifiers work in a 3D space in Blender. This tutorial is designed for beginners to help you grasp the functionality of all the modifiers available in Blender. So, without wasting any more time, let's dive right in. But first, let me introduce 3D.design, your gateway to a world of captivating 3D character models, icons, and more. Dive into our extensive library boasting artists, avatars, sleek cars, and diverse file formats compatible with tools like After Effects. Start your creative journey here for an immersive experience. Alright, let's begin. Well, we should probably start with, what is a modifier? Modifier is a non-destructive way of modeling. So non-destructive modeling means you can keep your original mesh, you can do a bunch of stuff with it, and if you're not happy with the results, you can remove the modifiers and you end up with your base mesh. So it's basically a very safe way of modeling, and that's the main advantage of using modifiers. Now we have a bunch of different categories in modifiers, so let's start with Generate Modifiers. The Array modifier helps you create multiple copies or instances of an object in a specific pattern or arrangement. It allows you to duplicate and arrange the object in a linear or radial fashion, making it easier to create repetitive structures or patterns in your 3D scenes. The Bevel Modifier adds rounded edges to the sharp corners of a 3D object. It creates a beveled or chamfered effect, smoothing out the edges and making them look less sharp and more visually appealing. This modifier is useful for giving objects a more realistic and polished appearance, especially when you want to avoid harsh, sharp edges in your 3D models. The Boolean Modifier allows you to combine or cut one 3D object with another. It performs operations like union, difference, and intersection. In simple words, it helps you create complex shapes by combining or cutting simpler shapes, providing a way to easily model intricate designs or cutouts in your 3D scenes. The Build Modifier gradually constructs or deconstructs a mesh object over time. It operates on the faces of the mesh, making them appear or disappear one after the other. The order of appearance can be the order of creation, or it can be randomized. This modifier is useful for creating effects like a structure being built or deconstructed in an animation. The Decimate Modifier simplifies a 3D model by reducing the number of vertices, while trying to retain its overall shape. It's like a simplification tool that helps optimize the geometry of a mesh. The modifier offers options to control the reduction level, allowing you to balance between lowering the polygon count and preserving the essential details of the object. It's commonly used for optimizing models to improve performance in real-time applications, or to simplify complex meshes while maintaining a reasonable level of visual quality. The Edge Split Modifier helps control how smooth or sharp edges appear on a 3D model. It works by splitting the edges of the model based on certain criteria, such as angle thresholds. When applied, it can make some edges look sharp while keeping others smooth, enhancing the visual appearance of the model. This modifier is often used to achieve a stylized or more defined look for certain edges without having to manually mark each one as sharp. The Mask Modifier acts like a magic hide and seek trick for your models. It uses special groups of vertices to selectively hide parts of an object, letting you reveal or conceal areas just like with a mask. Think of it as painting with invisibility. This comes in handy for creating dissolving effects, animating reveals, or simply focusing on specific sections of your model. The Mirror Modifier helps you create symmetrical 3D models easily. When applied, it duplicates one half of the object and mirrors it to the other side, creating a mirrored version. This is particularly useful for modeling characters, creatures, or objects that have a symmetrical shape, as it allows you to edit only one side while automatically updating the other side in real time. It simplifies the modeling process and ensures symmetry without the need for manual adjustments on both sides of the model. The Multi-Resolution Modifier allows you to work with different levels of detail on a 3D model. It creates a multi-resolution representation of your mesh, where you can switch between lower and higher levels of detail. This is beneficial during the modeling and sculpting process. You can start with a low-resolution version for quick edits and gradually increase the detail as needed. It provides a flexible way to balance performance and detail when working on complex 3D models. The Remesh Modifier helps you change the structure of a 3D model by redistributing its geometry in a more uniform way. It essentially remeshes the object, creating a new mesh with a more even distribution of vertices. This can be useful for simplifying complex shapes, fixing irregular geometry, or preparing a mesh for sculpting. The Remesh Modifier offers different algorithms and settings to control the level of detail and the overall appearance of the remeshed objects. The Screw Modifier allows you to create a 3D object by revolving a 2D profile around an axis, as if you were turning a screw. You provide a 2D shape and specify an axis of rotation. The modifier then extrudes and rotates the profile around the axis, creating a 3D shape. It's particularly useful for generating objects with rotational symmetry, such as screws, bolts, or other cylindrical forms. The Screw Modifier simplifies the process of creating these shapes, saving time and effort in 3D modeling. The Skin Modifier helps you create a smooth and connected surface around a series of interconnected vertices, or edges. It's like wrapping a 3D skeleton or wireframe with a flexible skin. When you apply the Skin Modifier to a set of vertices, it generates a surface that connects them, creating a more organic and continuous shape. This is particularly useful for quickly creating basic organic forms or character models. The Skin Modifier provides a convenient way to build a preliminary shape for further modeling or sculpting. The Solidify Modifier adds thickness to a 3D object by giving it volume and depth. It works by creating a new layer around the existing surface of the object, effectively making it solid rather than just a surface. This is useful when you want to give flat or thin objects some thickness, making them look more like three-dimensional objects. The Solidify Modifier is commonly used in various 3D modeling scenarios to add substance and realism to surfaces that would otherwise lack depth. The Subdivision surface modifier smoothens and refines the appearance of a 3D model by subdividing its surfaces. It divides the existing faces into smaller ones, creating a more detailed and smoother surface. This modifier is often used to enhance the visual quality of models, especially when working with low polygon geometry. It helps achieve a more rounded and polished look by adding extra subdivisions to the model's surfaces, making it appear more realistic and refined. Triangulate Modifier automatically breaks down all faces of a 3D mesh into triangles. This is useful for various reasons, such as ensuring compatibility with certain applications or simulations that work better with triangular geometry. The modifier provides different methods for how it should triangulate, like creating triangles based on beauty, fixed patterns, shortest or longest diagonals, and more. It's a quick way to adjust the structure of your 3D model for specific needs or preferences, without manually editing each face. The Volume to Mesh modifier turns a 3D volume into a mesh. It works by converting a specific type of data within the volume into a 3D mesh object. The modifier provides options to control the resolution of the resulting mesh, adaptivity for optimizing resolution, and the ability to define which part of the volume should be considered inside the mesh based on a threshold value. This allows for the conversion of volumetric information into a format that can be edited and rendered more conventionally in 3D modeling. The Weld Modifier looks for groups of vertices within a specified distance threshold and merges them. This process collapses the surrounding geometry, effectively reducing the number of separate vertices. The modifier offers different modes for choosing which vertices to merge, such as merging all geometry or only connected parts. You can set a maximum distance for vertices to be considered for merging. Additionally, there's an option to apply the welding effect only to loose edges that are not adjacent to any face. The Wireframe Modifier transforms a 3D mesh into a wireframe by converting its faces into four-sided polygons that represent the edges. It's important to note that the original mesh must have faces for the wireframe effect to work. Alright, now let's move to Deform Modifiers now. But first let's understand why do we use Deform Modifiers in 3D modeling. Well, Deform Modifiers helps you to reshape or distort objects in a 3D scene without directly manipulating their geometry. These modifiers allow you to apply various transformations to achieve effects like bending, twisting, or curving an object. The Armature Modifier allows you to connect a 3D model to a skeletal structure, commonly known as an armature. This armature acts like a virtual skeleton, and by applying the Armature Modifier to a mesh, you can make the mesh deform or move in accordance with the movements of the armature. In simpler terms, it's a way to animate characters or objects in Blender by associating them with a skeletal structure, enabling you to create realistic movements and poses. The Cast Modifier shifts the shape of a mesh, curve, surface, or lattice toward predefined shapes like a sphere, cylinder, or cuboid. It's similar to the To-Sphere tool in Edit mode. The modifier has options to choose the target shape, control the deformation factor, set a radius of influence, and use a specific object to control the effect. It's a versatile tool for transforming objects into various predefined shapes with customizable parameters. The Curve modifier allows you to deform or shape an object along the path of a curve. When you apply the Curve modifier to an object, it essentially makes the object follow the curve's shape. This is particularly useful for creating smooth and controlled bends, twists, or animations, as the object adjusts its form based on the curve's path. In simple terms, the Curve modifier lets you make objects follow the curves you define, adding flexibility and creativity to your 3D modeling and animation projects. The Displacement Modifier distorts the geometry of an object based on the values of a texture or another object. It displaces or shifts the vertices of the mesh, creating a deformation effect. Essentially, it allows you to use textures or objects to influence the shape of your 3D model. This can be useful for adding irregularities, terrain-like details, or other surface distortions to your objects in a controlled and artistic manner. In simpler terms, the Displacement Modifier lets you mold the shape of your object using external influences. The Hook modifier is used to deform a mesh, curve, or lattice by connecting it to another object, such as an empty or a bone. As the specified object moves, it pulls the connected vertices or control points along with it. This is similar to animated proportional editing, but allows you to directly select and manipulate specific vertices. The modifier panel provides options to choose the object to hook to, define influence using a vertex group, adjust strength. The Laplacian Deform Modifier in Blender allows you to pose a mesh while preserving its geometric details. You define a set of anchor vertices, move some of them, and the modifier calculates optimal positions for the remaining vertices to maintain the original details. It uses differential coordinates to capture local geometric information like curvature and direction based on neighboring vertices. You must specify an anchor's vertex group, and the modifier iterates to find the best solution, improving with more iterations. The anchor weights define the vertices used for transformation, and the bind button captures the geometry details. It's a powerful tool for precise and detailed mesh posing. The Lattice Modifier allows you to deform a 3D object by enclosing it within a lattice, which is like a 3D grid. The lattice acts as a cage around the object, and when you modify the shape of the lattice, it deforms the object inside accordingly. This modifier is useful for creating more complex and controlled deformations on a model, particularly when you want to shape or warp the entire object in a way that's easy to manage. In simple terms, the Lattice Modifier lets you bend, twist, and reshape objects within a 3D grid structure for precise and creative modeling. The Mesh Deform Modifier allows you to deform a 3D object by using another mesh as a deformed cage. You wrap the target object with a more flexible and detailed mesh, and the Mesh Deform Modifier makes the target object conform to the shape of the cage. This is especially useful for achieving complex and organic deformations in character modeling or animations. In simpler terms, the Mesh Deform Modifier lets you control and shape one object by surrounding it with another, more detailed object acting as a deformed controller. The Shrinkwrap Modifier allows you to make one object conform to the surface of another object. When applied, it wraps or shrink-wraps the vertices of the target object onto the surface of a specified reference object. This is useful for making objects adhere to the shape of another, such as making clothes stick closely to a character model or projecting details onto a surface. In simple words, the Shrinkwrap Modifier helps one object take on the shape of another by pulling its vertices towards the surface of the reference object. The Simple Deform Modifier in Blender is a tool that allows you to apply basic deformations or transformations to a 3D object. It works by bending, twisting, or tapering the object based on a specified axis and angle. This modifier is useful for quickly adding simple and controlled distortions to your models, providing a way to give objects a more dynamic or stylized appearance. In simpler terms, the Simple Deform Modifier lets you easily bend, twist, or taper objects in a straightforward manner. The Smooth Modifier in Blender smoothens a mesh by reducing the angles between adjacent faces without adding more vertices. It's like using the Smooth tool in edit mode. The control factor adjusts the smoothing amount, and interesting deformations can occur with values beyond the expected range. The modifier can also be used for selective smoothing by applying it to specific vertex groups. The algorithm moves each vertex towards the average position of its neighboring vertices, creating a blurring effect on the mesh, similar to the way images are blurred. The Smooth Corrective Modifier reduces distortion in a mesh, often seen around joints after using an Armature Modifier. It works by smoothing highly distorted areas based on a reference rest state. The factor controls the smoothing amount, and options include repeat, scale, and various smoothing methods. It can be restricted to specific vertex groups and offers a preview-only smoothing option. The smooth Laplacian modifier reduces surface noise on a mesh while minimizing changes to its shape. It can also exaggerate the shape with a negative factor, ideal for cleaning up objects reconstructed from the real world. It removes unwanted noise while preserving the essential geometry and the original model's shape. The modifier operates using a curvature flow Laplace-Beltrami operator in a diffusion equation. The Surface Deform Modifier in Blender is a tool that allows you to deform one 3D object based on the surface of another object. You specify a target object and a deform object. When applied, the Surface Deform Modifier makes the target object conform to the shape of the deformed object. In simple words, the Surface Deform Modifier lets you reshape one object by wrapping it around the surface of another object, creating complex and precise deformations. This is often useful for tasks like wrapping clothing around a character model or conforming an object to the surface of a detailed reference shape. The Warp Modifier warps parts of a mesh to a new location using two objects to define the from and to regions. It's like using proportional editing in edit mode. The from point pulls towards the to point. Options include setting the strength, preserving volume during rotation, and using vertex groups for control. Flow of options control the strength distribution, and textures can be used for fine control. It's useful for interactive proportional editing in animations or deforming parts of a mesh without creating a vertex group. The Wave Modifier creates a rippling or waving effect on a 3D object. It simulates the appearance of waves traveling across the object's surface. By adjusting parameters like speed, height, and width, you can control the characteristics of the waves. This modifier is often used for animating water surfaces, flags, or any object where a dynamic, undulating motion is desired. In simple terms, the Wave Modifier adds a wave-like motion to objects in your 3D scenes. Once we've discussed deform modifiers, next we have physics simulations. So let's start with cloth. The cloth modifier simulates the behavior of fabric or cloth on a 3D model. When applied to an object, it makes the object behave like a flexible material, responding to forces like gravity, wind, or collision with other objects. The cloth modifier is commonly used for creating realistic animations of clothing, flags, or any object that needs to exhibit cloth-like movement. In simple words, the cloth modifier allows you to animate and simulate the dynamics of fabric on your 3D models. The collision modifier serves as a container for collision physics, enabling interaction between different physics simulations. It is used to define collision properties for objects and simulations. The actual configuration options for collision behavior are found in the Physics Properties tab. The modifier allows objects to interact with each other in simulations, such as particles bouncing off surfaces or cloth reacting to obstacles. The Dynamic Paint modifier allows objects to interact with each other, leaving dynamic effects such as ripples, color changes, or wetness. It simulates the behavior of one object affecting another over time. For example, you can make one object paint onto another as it moves or changes, creating animated effects like footprints in the sand or color spreading on a canvas. In simple words, the Dynamic Paint modifier lets you simulate dynamic interactions between objects in your 3D scenes. The Explode modifier is used to create an exploding effect on a mesh by moving and rotating its faces based on particles emitted from the object. It requires a particle system on the object to control the explosion. The modifier alters the mesh based on the number of emitted particles and faces, creating a granular explosion effect. It should be placed after the particle system modifier in the stack. Options include particle UV mapping, control over displaying faces during particle states, cutting edges for a more random split, scaling faces based on particle size, and the use of vertex groups for selective influence. The modifier provides features to invert, protect, and refresh the effects. The Fluid modifier serves as a container for fluid physics simulation. It allows you to simulate fluid behavior on a low-poly mesh. The actual simulation options and settings are configured in the Physics Properties tab. This modifier is commonly used to simulate fluid dynamics in a scene, and additional modifiers, like Subdivision surface, can be applied afterward to enhance visual quality without significantly increasing simulation times. The Ocean modifier generates realistic animated ocean surfaces. When applied to a plane or mesh, it creates a dynamic ocean with waves, ripples, and foam. You can adjust various parameters such as wave height, choppiness, and scale to control the appearance of the ocean. The Ocean Modifier is commonly used for creating realistic seascapes or adding animated water surfaces to scenes. In simple terms, it simulates the natural movement and appearance of ocean waves in 3D animations. The Particle Instance Modifier duplicates an object's mesh at the locations of particles from a selected particle system on another target object. To use this modifier, you need a separate object with the particle system. The modifier's settings depend on the particle system's attributes, such as regular or child particles, and can be influenced by the size and state of particles. It allows for controlled duplication of the mesh, giving the appearance of instances based on the specified particle system settings. The Particle System Modifier enables the creation and manipulation of particle systems, allowing you to generate and control the behavior of thousands or even millions of tiny objects within a scene. These particles can represent various elements such as raindrops, sparks, fur, or any other instances you want to distribute in a controlled manner. You can adjust parameters like the number of particles, their size, movement, and appearance. The Particle System Modifier provides a way to simulate complex and dynamic effects, adding realism and detail to your 3D scenes. In simpler terms, it's a feature that helps you manage and animate large numbers of small objects in your Blender projects. The Soft Body Modifier allows you to simulate the flexible and deformable behavior of objects, as if they were made of soft, pliable material like cloth or rubber. When you apply the Soft Body Modifier to an object, it reacts to forces such as gravity, collisions, and other dynamics, exhibiting realistic deformation and movement. In simpler terms, the Soft Body Modifier helps you animate and simulate the soft, bouncy, or elastic nature of materials, making objects in your 3D scenes behave as if they are flexible and dynamic. Once we're done with the simulations, let's understand the capabilities of Edit Modifiers. The Data Transfer Modifier allows you to copy information, like colors or texture coordinates, from one mesh to another. It transfers specific data between two objects. The Mesh Cache Modifier is used to apply animated mesh data to a mesh, deforming it over time. It's similar to Shape Keys but is designed for playing back external files, commonly used for interchange between applications. The supported file formats include .mdd and .pc2. The modifier allows you to specify the file path to the cache file and adjust the influence of the deformation. The Mesh Sequence Cache Modifier loads animated mesh data from Alembic and USD files, supporting static and animated meshes, as well as curves. It handles file sequences and meshes, curves with varying topology. This modifier is automatically added when importing Alembic or USD files with time-varying data. Options include selecting the cache file, specifying the object path within the file, and choosing the type of data to read. Time-related settings allow handling sequences, overriding frames, and setting frame offsets for cache data retrieval. The Normal Edit Modifier affects or generates custom normals for a mesh. It uses parametric methods to compute normals, which is useful in game development and architecture. The modifier aligns normals either radially, making them seem to radiate from a specified center point, or directionally, converging towards a target object's origin. The Weighted Normal Modifier adjusts the custom normals of a mesh to achieve specific shading effects, such as creating flat faces. Enabled by Auto Smooth in Object Data Properties, it computes weights for combining normals based on face area, corner angle, or a combination of both. The weight parameter acts as a contrast control, influencing the strength of the weights. A threshold ensures rounding for weights close in value. It includes options to preserve sharp edges, use face weights, and limit the modifier's impact to a specified vertex group. The UV Project Modifier functions like a slide projector, projecting a UV map from the negative z-axis of a designated controller object, such as an empty or a camera, onto the target object's surface. It allows for adjusting aspects like UV map selection, image aspect ratio, and scaling. The modifier supports up to 10 projector objects, and each face selects the closest and aligned projector based on its surface normal. Common use cases involve diversifying spotlights or creating decals to add detail and variation to surfaces. The UV Warp Modifier allows direct control over an object's UV map in the 3D viewports. It enables users to move, rotate, and scale existing UV coordinates using specified values or two objects as controllers. The modifier includes options for selecting the UV map. The Weight Edit Modifier in Blender is designed to modify the weights of a vertex group. It follows a process for each vertex, involving optional mapping through predefined functions or a custom curve. The modifier then applies an influence factor along with an optional vertex group or texture mass, where 0.0 indicates the original weight and 1.0 denotes the fully mapped weight. After applying the weights, the modifier may optionally remove vertices from the group if their weight falls below a specified threshold, or add them if the weight exceeds a given threshold. In essence, it provides a flexible way to adjust vertex weights based on mapping functions and thresholds. The vertex weight mix modifier blends two vertex groups using different operations. It mixes the weights of one group with another group or a simple value. The modifier provides options to invert weights, set default weights for vertices not in the specified groups, and choose the set of vertices to be affected. The mix mode determines how the weights are combined, including options like replacing, adding, subtracting, multiplying, dividing, finding the difference, averaging, or selecting minimum or maximum values. Additionally, there's an option to normalize weights, scaling them within the 0 to 1 range. This modifier is useful for adjusting and blending vertex weights for various purposes in 3D modeling. The vertex weight proximity modifier adjusts the weights of a specified vertex group based on the distance between the modified mesh object and a target object or its geometry. It calculates distances in different modes such as object distance or geometry distance. The modifier sets vertex weights proportional to the distances, clamping values between 0.0 and 1.0. Last but not least, we have geometry nodes. Well, in simple terms, the geometry nodes modifier allows you to create and manipulate 3D geometry in a flexible and procedural way. Instead of manually modeling every detail, you can use nodes to define rules and conditions for generating or modifying your 3D objects. It's like setting up a series of instructions or recipes to create, transform, or scatter geometry, making complex tasks more manageable and dynamic in the 3D design process. And finally, that brings us to the end of this video. If you really enjoyed this, consider subscribing and giving this a big thumbs up. Do check our vast collection of 3D character models at 3D.design, and I'll catch you in the next one. Thanks.